Today's video lesson starts on page 9 of our notes, so we'll be covering actually pages 9 and 10 of our chapter 1 notes. Solving quadratic equations by factoring. Hopefully you recall this from a previous math course. A quadratic equation in standard form is ax squared plus bx plus c equals 0. Steps to solve. Write the equation in standard form if it isn't already in standard form. Factor, and then solve by setting each factor equal to 0. Recall that if it's not factorable, we would use the quadratic formula. Our first problem, solve 5x squared plus 34x minus 7 equals 0. It's already in standard form, so we try to factor it. Lead coefficient is 5, it's not 1. So we multiply 5 times 7 is negative 35. And now we look for the factors of negative 35 that add to positive 34. And that would be 35 and negative 1. Draw a fraction bar. Remember, this is our factor in, factor out. That lead coefficient of 5 goes in the denominator and starts both parentheses of our numerator. So this is going to be 5x plus 35 and 5x minus 1. Now 5 divides evenly into 5x plus 35. So divide it in x plus 7, and then our other factor 5x minus 1. So this is a factorization of the trinomial. And remember, we're still working with an equation, so copy down the equal 0. And now set each factor equal to 0. X plus 7 equals 0. 5x minus 1 equals 0. Solve individually, subtracting 7 from both sides. X equals negative 7. Adding 1 to both sides. 5x equals 1. And divide by 5. So x equals 1/5. So we have two solutions here. We have negative 7 and 1/5. And I'm going to write the solution in solution set notation, negative 7, 1/5. Our next problem, 10x squared equals 6x. First, write it in standard form. So subtract 6x from both sides. 10x squared minus 6x equals 0. Now we factor. There's only two terms here. First thing, there is a greatest common factor, so factor out the GCF, which is 2x, and 5x minus 3 results. This is in factored form. Set each factor equal to 0. 2x equals 0, 5x minus 3 equals 0. Divide both sides by 2 here, x equals 0. Add 3 to both sides, 5x equals 3, and divide by 5, x equals 3/5. So we have two solutions here, 0 and 3/5. It's not necessary to check these. If you wanted to, you could. You would just take your two roots, solutions, one at a time, and plug them into the original equation. Next, number 3, 16x squared minus 9. It's in standard form. Recognize this as being the difference of two perfect squares. Difference of two squares. So this factors into x plus 3. 4x plus 3 times 4x minus 3. Again, continue with our equation equals 0. It's in factored form. Now you set each factor equal to 0. And then solve each equation individually. So subtract 3. 4x equals negative 3. Divide by 4. X equals negative 3/4. And here, add 3 to both sides. And it's not necessary that you show every step here. I know a lot of you can just add 3 to both sides and divide by 4. all in one step and come up with the answer of 3/4. So two solutions here in solution set notation, -3/4 and +3/4. And number 4, we have 4x squared equals 20x minus 25. It's not in standard form, so we must put it in standard form. Our quadratic term, the 4x squared, is by itself, but where it is, it's positive. We always want to start off whenever we're factoring. We would like our quadratic term to be positive. So let's leave 4x squared there, and we'll bring these other two terms on the right-hand side over to the left-hand side by subtracting 20x and adding 25. So we have 4x squared minus 20x plus 25 equals 0. No GCF to these three terms. Lead coefficient is not 1, it's 4, so we multiply 4 times 25, that's 100. And the factors of 100 that add to -20 are -10 and -10. Draw a fraction bar. The lead coefficient 4 goes in the denominator and starts off both our binomials of the numerator. 4x minus 10, 4x minus 10. 4 doesn't divide into either parenthesis evenly, so we break 4 down into 2 times 2 and then divide each by 2, resulting in 2x minus 5 times 2x minus 5. Again, we're working with an equation, so let's bring down our equals 0 and set each factor equal to 0 and solve. Add 5 to both sides, 2x equals 5, divide by 2, x equals 5/2. And the same for our other equation. We're going to end up with x is equal to positive 5/2. So this is what's called a double root. And when we write the solution in solution set notation, we need to only write 5/2 once. Of course, decimal equivalents are always acceptable. If you prefer to write 2.5, that's fine. And our last quadratic equation that we're going to solve by factoring is 2x squared minus 30 equals 4x. Well, we need to put this in standard form, so we subtract 4x from both sides. Again, it's not necessary that you show that step. I was about to go and multiply 2 times -30, but caught myself. There's a GCF here of 2. So we factor out the GCF 2, x squared minus 2x minus 15 equals 0. We look at our trinomial in parentheses. Now the lead coefficient is 1, so are there factors of -15 that add to -2? -5 and +3. So that's x minus 5 times x plus 3. Bring down the GCF of 2 equals 0. So we have 3 factors here, 2, x minus 5, and x plus 3. We set each one equal to 0. But 2 equals 0, that's not a true statement. So let's just cross that off. So x equals 5 and x equals -3. Now turn to page 10 of the notes, okay? And this is new view. This is solving quadratic inequalities. To solve a quadratic inequality, you find the roots or solutions of the corresponding equation. Mark these roots on your number line with an open or filled in circles, depending on whether it's a less than or equal to, greater than or equal to. If the inequality is less than or equal to, you shade between the roots. In other words, I have this number line here, so if I just mark circle, if the inequality is less than or equal to, you shade between. Remember, that's going to be our and inequality. Just like with absolute value inequalities, if it was less than or equal to, our shading would be between the two values. And now here, if the inequality is greater than or equal to, you shade outside the two roots. So if these are our two roots, we would shade outside or in the opposite directions. There is an alternate method of picking a test point, but I'm not going to emphasize this. Okay, so our first example here, we have solve x squared minus 2x minus 15 is greater than or equal to 0. So we have this quadratic inequality. Instead of an equation and equal to 0, we have greater than or equal to 0. And we're going to express our solution graphically, symbolically, and in interval notation. So we're finding the roots of the corresponding equation. That's the first step. So I'm changing this to x squared minus 2x minus 15 equals 0. And we're going to find the roots of that quadratic equation. The factors of negative 15 that add to negative 2 are negative 5 and 3. So this is x minus 5 times x plus 3 equals 0. Set each factor equal to 0. And solve. Again, I'm not showing every single step here. So x equals 5 and x equals negative 3. These are our two roots, or solutions. So we go to the number line. Place negative 3 and 5 on our number line. Circle each. Now our original inequality was greater, right? Remember that. Was greater than or equal to. So the equal to part means we fill in our two circles here. And a greater than means we're going to shade outside these two values. Okay, so now what we have symbolically is what's shaded here are all numbers that are less than or equal to negative 3. So x is less than or equal to negative 3. Or x is greater than or equal to 5. Now, interval notation, what's shaded? From negative infinity to negative 3 includes negative 3, so we have the bracket. Union with 5, 5 is included, so we have bracket 5, comma, infinity. Our next example we're working through is we're asked to solve x squared plus 6x plus 8 is less than 0. And again, express our solutions graphically, symbolically, and using interval notation. So we take our inequality and express it as an equation, keeping in mind that this is a less than symbol, so that's going to be the and. We will shade between. Factors of 8 that add to 6 are 4 and 2. So this is x plus 4 times x plus 2 equals 0. Set each factor equal to 0. And solve. X equals negative 4 and x equals negative 2. Place negative 4 and negative 2 in their appropriate places on the number line. Right? Negative 4 is smaller than -2. Circle each. And our original inequality was less than, so we are going to shade between. So this is a graphic solution. Now, symbolically, we have all values of x between these two integers. So what I like to do is just copy down the two integers and put x between them. Less than, less than. So if I read this, x is greater than -4 and x is less than -2. Interval notation, we only have one shading here, and it's between -4 and 2, and it does not include those two values, so it's open parenthesis, -4, comma, -2. You can try the two on your own, or you can continue to follow along. So if you want to try the two on your own, pause the video. If not, continue it. All right, I need to put this in standard form first, so let's subtract 2x and subtract 10 from both sides. And combining like terms where appropriate. So we have x squared minus 6x minus 16 is less than or equal to 0, right? Now solve it as if it's an equation. So let me actually change it to an equation, keeping in mind that our original inequality is a less than or equal to, so that's going to be an and, that's just shading between. The factors of -16 that add to -6 are -8 and 2. So x minus 8 times x plus 2 equals 0. Set each factor equal to 0. Again, you can skip this and go right to the two values. Add 8 both sides here. X equals 8. And subtract 2, x equals -2. So we draw a number line. Place our two values for x, -2 and 8. Circle each. And because our original was a less than or equal to, we shade in or fill in these circles. And we shade between. Symbolically, these are all values of x that are between -2 and 8. And let's not forget, also equal to. And interval notation, -2 is included, so it's bracket, square bracket, -2, comma 8, close bracket. And our final problem, 2x squared plus 7x plus 3 is greater than 0. It's a greater. For factoring, it's already in standard form, but again, let's write it as an equation. Multiply 2 times the constant 3, we get 6. The factors of 6 that add to 7 are 6 and 1. The 2 is our denominator and starts off each parenthesis of our numerator. 2x plus 6, 2x plus 1. 2 divides evenly into the 2x plus 6, x plus 3 times. 2x plus 1 is our other factor we just bring down. And now set each factor equal to 0. Subtract 3 from both sides, x equals -3. Subtract 1, 2x equals -1, and divide by 2, x equals -1/2. Now let's take those two values, draw a number line. -3 is smaller than -1/2. So -3, -1/2. circle each. Was gray tor was our original, so we know that our shading is going to go outside these two values. So there's our there's our graphic solution. Now symbolically, what's shaded here is all values that are less than -3. So x is less than -3, or x is greater than -1/2. And interval notation, we have two sections that are shaded. So two intervals, parenthesis -infinity to -3. Again, open parenthesis, union with, or you can write the word or, parenthesis -1/2 to infinity. And that concludes our Chapter 1 notes.